Today's learning target is I can write and evaluate expressions using exponents. Today we're going to be talking about powers and exponents. And just a reminder of what powers and exponents are. So exponents tell us how many times a number is used as a factor. So our exponents here are right here. These are the different exponents in these examples here, and they tell us how many times a base number is multiplied by itself. So in this one, 5 to the first power would be 5 would be the only factor. Now in this one, 5 to the second power, or we can say 5 squared, would be the same as 5 times 5. Okay, the exponent tells us how many factors of 5 there are. In this one, 5 to the third power, or 5 cubed, would be 5 times 5 times 5. In 5 to the nth power, the number of factors you would have for 5 would be how many, whatever n equals, would be the number of factors you would have for 5. Now let's take a minute to look at this one right here, where we have what's called the 0 power. So in this case, 5 raised to the 0 power. Any base number, like this 5, with the exception of 0, any base number that's raised to the 0 power is always going to be 1. Okay, so it doesn't matter if it was 6 to the 0 power, that would equal 1. If it was 12 to the 0 power, that's going to equal 1. Okay. Now there's a reason for this. It's not just some rule that mathematicians made to confuse math students. Let's take a look at why it is. Let's take a look at this problem right here. We have 3 to the third power divided by 3 to the first power. Now 3 to the third power written out would look like this, 3 times 3 times 3, divided by 3 to the first power would look like this. Okay, and that would end up equaling 27 divided by 3. And we know that that would equal 9. Now another way to solve this would be to simplify first. So I could simplify those right there. And if I do that now, I'm left with 3 times 3, which equals 9. Now let's take a look at how that relates to this division problem. So if I'm dividing exponents like I am here, I can take the exponents and I can subtract them. So here I have a 3, an exponent of a 3. Here I have an exponent of 1. So 3 minus 1 would be 2. So I'm left with 3 to the second power, which is the same as 3 times 3. And if you look up here, that's what I was left with here. And that equals 9. Let's look at one more example here. So I have 2 to the fifth power divided by 2 squared. Okay, here's what it looks like if I write it out. And I know I could cancel out those, right? They become 1. Those would become 1. And I'm left with 2 to the third power in this. Now, if I just take my exponents and subtract them, I'm left with 2 to the third power. Now let's go back to this. 3 to the 0 power is 1. So here's a problem that would end up being 3 to the 0 power, right? Because I can subtract my exponents. Okay, 3 minus 3 is 0, so this would give me 3 to the 0 power. Now let's go right here. I wrote it out, and let's start canceling out, right? I get those two cancel out. They become 1. 3 divided by 3 becomes 1. 1, 1. I'm left with 1 over 1, which is 1. So 3 to the 0 power would be 1. And remember, that works for any number. It could be 4 to the 0 power would equal 1. 10 to the 0 power would equal 1. The only number it won't work with is 0. You can't do 0 to the 0 power. Let's take a look here at how we would write these three expressions using exponents. So in this first one, I can see I have negative 6, and I have it 3 times. I have 3 factors of negative 6. So I'm just going to have negative 6 with the exponent of 3. Okay. Now in this one, I have 3 different factors. I have 5, I have a set of A's and a set of B's here. So in this case, I have 5 times A, and there's 3 of them, so A to the third power, or A cubed, times B to the second power, or B squared. So that's how I would write that one. Now in this third one, I have a set of R plus 3, and another set of R plus 3 right here. So in this case, I'm going to have R plus 3 and there's 2 of them, so it's squared. So let's take a look here at how we would solve 3 different expressions here. So in this first one here, we've got a to the 3rd power plus 2. Our first step is going to be to plug in the numbers that we have up here for any variables. So I see up here that a equals 3, so I'm going to fill that in for the a. So I have a to the 3rd power. Anything to the 3rd power can also be called cubed, so this could be 3 cubed, plus 2. Okay, so keep in mind today that you're going to want to show your steps as you're doing these. Okay, so 3 to the 3rd power I know is 27 plus 2. This shows my thinking, and when I add that, it's going to be 29. So we solve it just like that. Now as I solved this one, I didn't really refer back to my PEMDAS, which I probably should have, but it was a simpler problem. I knew that I do the exponents first and then I add later. This one's going to be a little more complex. So I want to be sure to refer to the PEMDAS. So I'm going to, first things first, fill in b is -4, okay, minus 1, and that's squared. Now I know in PEMDAS I do parentheses first, so I have -4 minus 1, and I know that's going to give me -5, and now I'm going to fill out the rest of what's left in this equation. And now I have a multiplication problem here, but I have an exponent here, and exponents come before the multiplication and division step. So I'm going to do -5 squared. And that would be -5 times a -5, which would give me a positive 25. And now that leaves me with that timesing it by 3, which would be 75. Notice how I'm showing all my steps. And my last one, c to the 2nd power. And the 2nd power, I can, instead of saying the 2nd power, I can say squared. So I could say c squared plus b to the 0 power. So first I plugged in my numbers for my exponents. And here 3.5 or 3 5/10 squared gives me 12.25. Okay, and that's going to be plus -4 to the 0 power. Remember, everything to the 0 power is 1. So now my final answer is going to be 13 and 25 hundredths.